Morning. So what we're going to be talking about today is what we were just kind of talking about with inverses. And we're going to be talking about inverse trig. So we're going to be talking about inverse trig today. And so what we just said that inverse meant, inverse means to undo. So in the general form, if you inverse it, you undo what you normally were doing. So trig was to find a side with an angle and a side. So the inverse trig is to find an angle with a side. So you're doing the opposite. It's the inverse. And we're still using SOHCAHTOA, all the trig identities. We're just doing the opposite. So we're going to do two examples. So example one, say we had a triangle that looks like this, where this is going to be my theta or my reference angle. And the information I'm given are these two sides for 5 and 7. So just like always, the first thing we're always going to do is we're going to label. So I'm going to look, my hypotenuse is always across from my right angle. That's my hypotenuse. I'm going to cover my reference angle, and the side I'm not touching is my opposite. And the side that's in between my two angles is my adjacent. So the first thing you always want to do is you always want to label. After you label, I think I spelled label wrong. Sorry. After you label, you can find your trig function. So remember, we have sine, cosine, and tangent. So we have our sine, our cosine, and our tangent. So our SOHCAHTOA, this is an A over H, sorry. That's an A. So we have our sine, cosine, and tangent. So in this case, the information given to us is an opposite and adjacent. So looking at our trig functions, it's our tangent that we're using. So we have the tangent of our reference angle is whatever our opposite over adjacent is. Normally when we do this, we're like, okay, we plug in our angle and then we plug in either our opposite or adjacent, whichever one is given to us. In this case, we don't actually know this angle. That's what we're looking for. And we know the opposite and the adjacent. So I'm going to plug it in just like I'm used to. So I have the tangent of whatever my reference angle is equals my opposite, which is 5, over my adjacent, which is 7. And at this point, you may be like, okay, but how do I put this into my calculator? This isn't anything. This is where the inverse comes in. So there is an inverse ratio for the tangent. And the way that you show inverse is with a little -1. So what I mean is by going like this little -1 means you're undoing it. And to undo this side, you're just going to have your theta will equal, and then whatever you do to one side, you have to do to the other. So you would have this tangent with a little -1 of 5 over 7. And from here, you can just put it in your calculator. And the way that you put it in your calculator, remember you want to use your Desmos calculator because your what is it called? Your phone can do weird things. Is we're used to using sine, cosine, and tangent from here. But we need that little -1 to show the inverse. So you can go and you can press function. That's what this means right here. And they're all right here. So we had tan to the -1, and we had 5 divided by 7. And that's my answer. So my theta would be 35.5. So we want to round to 1 decimal place in this case. So again, it'll usually show up like this. To find the little inverse tangent, you go to function, and it's right there. This is inverse cosine, inverse sine. So let's go back to our notes. Okay, so we found out from our calculator that our angle was 35.5. And we're done. Let's try another one. Let's try example 2. And let's make our triangle look something like this. So we have our right triangle. This is our missing angle that we're looking for. We're going to say this side is 3 and this side is 11. First step, no matter what, no matter if you're searching for an angle or if you're searching for a side, when you're using trig, you want to label the sides. So I'm going to cover this up. What it's not touching is my opposite. Across from my right angle is my hypotenuse. And then between my 2 angles is my adjacent. So in this case, the information given to us, we have an A and an H. So we look at our SOHCAHTOA. The one with the A and the H is our C. So it's our cosine of theta equals our A over H. Now I'm just going to plug in what I know. Ooh, sorry. So I have cosine theta. So my adjacent is 3 and my hypotenuse is 11. Now, because we want to find the theta, we have to inverse. We have to undo it. Because if we undo it, we're going to have whatever this is equals, to get rid of this, I took the inverse, so we had that little -1 of 3 over 11. So the only thing you're really changing is to move this to the other side. To do the opposite is you're finding the inverse of that 3 over 11. Again, I'm going to go back to my Desmos calculator because it will help me figure it out. So I want to make sure I'm on function. Then I do the cosine with the little -1, and I have 3 divided by 11. So in this case, I have 74, I'm going to write it, 74.17. So when we're working with decimals and we're working with degrees, we want to make sure we're rounding to 1 decimal place. So right now, this has 2 decimal places. So it has 2 numbers after the decimal. We want to look at this second number because it's going to tell us what we're going to do with that 1. And because 7 is bigger than 5, that means we're going to round up. So this 1, we're going to add to it. So it's actually, our answer would be 74.2 degrees. If you keep it at 74.1, that's like me telling you you have $74.10 instead of $74.20. And 17 is closer to 20 than it is to 10. So that's how you can think about, is it closer to 10 or is it closer to 20? And that'll tell you if you should round up or round down. So we're going to do some practice. Make sure you're asking questions, but you got this.